Welcome all of you. So today we will be starting a new topic. It is analytic hierarchy process, and it is one of the multi-criteria decision making methods. For example, whenever there is a challenge or a question in front of us, like suppose there is a problem and then there are multiple solutions to it, then how do we choose the best solution? Okay. So obviously we will have to find out certain criteria based on which we can select which solution is better or the best. Sometimes it may happen that there are more than 3, 4 or more than 5, 6 solutions, and then more than 5, 6 criteria on the basis of which we have to make a decision. So in that case, it's not easy. Also, it may happen that sometimes some criteria are quantitative in nature, which you can measure, but sometimes criteria can be qualitative in nature, like safety, reliability, well-being, which we cannot measure. So in such cases, multi-criteria decision making methods like analytic hierarchy process becomes useful. And in this course of environmental planning and management, there would be many occasions where you would be having multiple criteria based on which a decision has to be taken. Okay, maybe choice of best EIA method or choice of best type of planning that we have to consider for a given case study. Okay, so there can be problem statements like this where there will be multiple solutions and multiple options amongst which we have to choose one. So there this analytic hierarchy process or in general multi-criteria decision making methods would be helpful. So today we will be talking about what are these, just a brief overview about what actually is multi-criteria decision making method, what is AHP, analytic hierarchy process, and what are the basic steps like the mathematical calculation steps in AHP. And in the subsequent lectures, we will see how AHP can be applied to real world case studies related to environment. So multi-criteria decision making. It is a set of systematic methods used to evaluate and choose among alternatives that involve multiple conflicting criteria. Okay. So it is obviously some set of methods or tools which we can use to find the best alternative or the best amongst all the alternatives. These alternatives would involve multiple criteria, and often they are conflicting criteria, because if they are non-conflicting criteria, it would be easy to just average out or sum up the scores of different alternatives under all the criteria, and we can say like the higher value is the better one or the lower value is the no, it's not so better. So conflicting criteria means, let's take one example like cost and efficiency. What will happen, like if efficiency of any system has to be increased, it will obviously add some cost. Okay, it would be very difficult to increase efficiency and reduce the cost. Similarly, if you talk about like say emissions, if we wish to reduce the emissions, we will have to increase the efficiency, and it will be at the additional cost. So now in this case, efficiency and cost, they are not the conflicting criteria, but emission is a conflicting criteria to both efficiency and cost, because when one increases, the other decreases. When other increases, this one decreases. Okay. So this set of MCDM or multi-criteria decision making methods, it helps decision makers to make a rational, transparent and justifiable choice when no single criteria is sufficient to decide. Let's take one hypothetical scenario, like when you take a kid to a ice cream parlor, there are say 7, 8 flavors, and the kid decides which flavor to choose. It's purely based on their previous experience, that maybe the taste is the only criteria. And if someone likes mango ice cream, they will just say, okay, I will go for mango. So there's a single criteria, and it's easy to choose, even though there are so many alternatives. There are so many ice cream flavors, but if someone preferring some special ice cream because of just taste, that is a single criteria, it would be easy. But now where there are multiple criteria, if you take it from a parent's perspective, okay, so kids taste, it's one factor, the cost, the price of the ice cream may be another factor, the size of the particular ice cream, if some particular flavor is available in only in the big size, then you won't want the kid to eat a big size ice cream. Okay, so there are multiple criteria based on the parent's preference. So you see, as soon as the decision maker change for the same problem, the criteria would change, the preferences to those criteria would also change. Okay, and most of the time lot of criteria would be conflicting type, like I said, cost versus environmental impact, forest conservation versus infrastructure development. If a project has to be constructed, built, a new infrastructure has to be erected, it is going to come at the cost of forest conservation. We cannot, it would be very difficult to have both moving in the same direction. Okay. So, multi-criteria decision making supports decisions in such complex real world problems where trade-offs are unavoidable. Okay. Suppose if there are two parameters and if there is a trade-off. So, we can say, okay, choose any value between this zone and it will give you the preferred set of solution. But if there are multiple criterias, okay, and if some criterias are, their variations is very complex, it will be difficult to choose just from the trade-off. So, in such complex real world situation, multi-criteria decision making helps to take a decision. So, why MCDM? It is essential when multiple criteria must be considered simultaneously. Okay. If we choose one criteria at a time and do the comparison, it is relatively easier. But if different criteria has to be considered or accounted for simultaneously while finalizing the best set of alternatives, when we try to do it simultaneously without some mathematical tool, it will be very difficult. So, these kind of methods would be helpful in such cases. Also, when criteria have different units, scales and importance, we often say like you cannot compare apples with oranges, right? Whenever someone tries to do some comparison, this is the phrase you often hear, like you are comparing apples to oranges. Can we really compare apples versus oranges? Okay. If it is purely a mathematical problem of say addition or subtraction, maybe we won't be able to compare it, because it will be like 2 apples plus 2 apples can give us 4 apples, but 2 apples plus 2 oranges will always be 2 apples plus 2 oranges. It won't give us 4 apples or 4 oranges. We can call it as 4 fruits, but yeah, that is the way, like things like this can be accounted for in multi-criteria decision making. So, criteria can have different units, different scales, different importance, and they can all be accounted for. Stakeholder perspectives differ. Like I just give you the example of ice cream. Like with respect to the consumer, like the kid, the perspectives are different. With respect to the parent, like the buyer, the perspectives would be different. And decisions must be evidence based, like EIA, environmental management system, policy, planning. So, all these tools which are based on lot of discussion, strategies and data or the expert opinion. For that, when these kind of methods are applied, we can say like the decisions that we are getting out of these methods are evidence based. They are not like based on some randomly thrown numbers, but based on the preferences given by experts or based on the data collected under these different categories. So, some examples where multi-criteria decision making can be used: selecting a renewable energy technology. Suppose there are multiple options available like solar, wind, hydro, biomass, which one you select depending on a particular region. Prioritizing environmental impacts or aspects in EMS, environmental management system. Ranking the waste treatment options. There are so many technologies to manage waste. So, which one we go for? Choosing hydropower sites. If there are multiple locations where a hydropower plant can be installed, then how do we choose the best site? So, problems like these can be the examples for MCDM. There are two broad types of multi-criteria decision making methods. One is multi-attribute decision making. In this case, what happens? The number of alternatives is finite. So, it is usually used when the discrete options, the known number of options are to be compared. The common method is AHP, ANP, Analytic Network Process, and TOPSIS. It stands for Technique for Order Preference by Similarity to Ideal Solution. And the second type is multi-objective decision making, and this is used when alternatives are infinite, and in that cases we typically use optimization processes like Pareto optimization or genetic algorithms or multi-objective linear programming or non-linear programming. Okay. And then the third, it is not a type, but if we have the combination of more than one methods, we typically call it as hybrid multi-criteria decision making method, which combines two or more methods to improve the robustness of the decision making process. So, it can be AHP Topsis, AHP Promethi, AHP Fuzzy Topsis, or Fuzzy AHP versus Fuzzy Topsis. So, there can be n number of hybrid methods depending on how many individual methods are there, and can we really merge them. So, number of alternatives being finite, these are most real world problems where you have like say 5-6 alternatives, you have to choose one. But can you think of a problem where alternatives are infinite and where you need the optimization? For example, if you have to find the best set of conditions for conducting gasification of biomass or pyrolysis of biomass. So, what set of temperature, heating rate and residence time you want to choose? There is a huge range from 300 degrees Celsius to 900 degrees Celsius. For heating rates, there is a huge range. For residence time, there is a huge range. So, in each point would be a alternative. So, there are infinite alternatives possible. So, in such cases, we often employ this optimization based approach. So, those are called multi-objective decision making. The first one is multi-attribute decision making. So, in this course, we will be focusing mainly on one of the most widely used methods, that is analytic hierarchy process, AHP. So, AHP was developed or proposed by Thomas L. Sati, a mathematician and operations researcher in US, while his group was working on complex military and government planning problems in 1970s. And it is a structured multi-criteria decision making method. It is one of the most widely used across different sectors like engineering, banking, policy making, EIA and energy sector. Okay. And it helps to compare alternatives when decisions involve both qualitative and quantitative criteria. I mentioned this earlier also. For multi-criteria decision making methods, it is possible to compare apples versus oranges. Okay. Qualitative and quantitative criteria we can compare. It combines qualitative judgments and quantitative analysis, which makes it suitable for different environmental applications like environmental planning, EIA, EMS, resource prioritization or policy decisions. So, because it can take care of qualitative judgments given by experts or decision makers and quantitative analysis like the data collected from site inspection or from literature, and hence it is suitable for these aspects like these fields related to environment where both the judgments and quantitative data are involved. So, first let me show you like a typical AHP tree structure, and then we can move on to steps in AHP. So, it uses like as the name suggests, analytic hierarchy process. So, it uses a tree or a hierarchy structure of objective criteria. Criteria may have some sub criteria and alternatives, so that a complex real world problem or decision making problem can be represented in a simplified sub problem. For example, level 1, it is a goal and objective, goal or objective, it is like more generic, and it can be choosing the best set of renewable energy or choosing best technology for wastewater treatment. Then the level 2 is criteria and sub criteria. So, criteria can be multiple, and each of the criteria can have multiple sub criteria, or they can be just C1, C2, C3, C4. Okay. And then level 3 is the alternatives, different types of technologies that are available for treating wastewater. So, those will form our alternatives. So, more general to more specific, goals to criteria to alternatives. 3 levels, it forms the hierarchy structure. So, that is the analytic hierarchy process tree structure. Now, coming to the key steps. So, first step is as you saw in the level 1, that is define the goal. Clearly state the decision problem, like example, select the best renewable energy technology or choose best waste treatment option. Like waste can be treated by landfill, by anaerobic digestion, by combustion, incineration. Okay. So, that can be a goal which is very like though generic, but it is specific and measurable and decision oriented. The question which we are asking in these goals will have some solution which can be conveyed as a decision. Okay. Amongst the renewable energy technologies, solar PV is the best one. Amongst waste treatment option, incineration or gasification is the best one. Okay. That gives you the specific measurable answer. Structure the hierarchy. So, once the goal is set, you organize the problem into 3 levels or 4 levels depending on whether there is sub criteria or not. So, on level 1 you have goal, criteria, then in level 2 sub criteria, and then finally alternatives. The tree structure, you make the tree structure. Step 3, make pairwise comparisons. So, compare each element against every other element using that is 1 to 9 scale. So, how do, like, if I have to compare A with A, it's the value will be 1, isn't it? A is equally important with respect to itself. So, the value here would be 1. Now, if I have to compare A with, like, say B, and if I say B is 2 times importance than A, so here the value would be 2. Okay. So, if emission is strongly more important than cost and emission has value 5, and if E is preferred over C, then C versus E cell in the matrix will get the reciprocal 1 by 5. Let us do it here again one more time. A, B, C. If I take the 3 criteria, okay. So, A is equally important with respect to itself, B is equally important with respect to itself, and C is equally important with respect to itself. So, the diagonal elements are going to be 1. Now, if B is more important than A, and if I give it the value 2, and if I say C is more important than B, let me give it value 4. So, now since when we say B is 2 times more important than A, it means A is half, like 1 by 2 times important as B. So, the reciprocal, once you get the numbers here in the first column of the matrix and the diagonal matrix is filled, the other remaining part of the matrix can be filled using the reciprocal law. So, here it will be 1 by 2, it will be 1 by 4, and now since it is reducing row wise, like 1 half, 2 to 1, so it will be 4 to 3 and 1 by 3. This I will explain in detail when we solve numerical, but this is how the matrix would be filled, and this matrix is called as pairwise comparison matrix. So, the pairwise comparison matrix is typically obtained first for criteria and then for the alternatives. So, like I said, scale of SATI 1 to 9, and the scale starts from 1, goes all the way till 9. When we say 1, it is the equal importance, which says both the elements contribute equally. 2 is the weak importance, 3 moderate, moderate plus, then strong importance, very strong, and extreme importance is the number 9. So, 9 means highest level of importance. Okay. So, NR is numerical rating, and the reciprocal values would be used when reverse comparison is made. Like I said, if B is 2 times more important than A, then A would be half times important as B. Okay. So, if B is 9 times more important than A, then A would be 1 by 9 times like less important or more or important. I won't use more or less, and 1 by 9 times important than B. So, that is the reciprocal values. So, using this scale, so actually this scale, then you can say it starts from 1 by 9, 1 by 8, 1 by 7 all the way to 1, 2, 3, 9. Okay, that is the scale, and if you just deal with like one step at a time, you can see it has got 9 and 9, almost 18 numerical values. So, third step was make pairwise comparison, and once you do the pairwise comparison for the given data, you compare each element in the matrix against every other element using that scale, and the output of this stage is a pairwise comparison matrix, and you obtain this matrix for each level, for criteria first and then for alternatives. So, let me take one more example here. Let us assume 3 criteria A, B, C, and based on the literature data or the expert judgments, if it is found that C is strongly more important than A and moderately more important than B, and B is moderately more important than A. So, this is the data that we obtained after consulting the experts or doing a survey. So, how we can represent it? ABC versus ABC, that is a pairwise comparison matrix, PCM, for criteria. So, diagonal elements are 1 because A is equally important to A, B is equally important to B, C is equally important to C itself. Now, data says C is strongly more important than A. So, if A is 1, C is 5. it's very strongly important, more important than A, and moderately more important than B. So B is 3. We don't know whether B would be 3 or not, but we know that it would be something less than 5, because C is going to be more important than B, and there is no relation between B and A till this point. But here it says B is moderately more important than A, which means we can assume B as a 3. So 1, 3, 5, these are the numbers. So you fill the reciprocal of this. And now this 3 to, how did this number come? So you just check the row above. So 3 to 1, it is reducing by 2 numbers, shifting by 2 numbers down in the scale. So from 5, it will shift 2 numbers down. So it will be 3, and then this will be reciprocal of that, 1 by 3. That is how you fill the matrix. So that was step number 3. Now step 4. So once you calculate the pairwise comparison matrix, you find the weights or priority vectors for each comparison matrix. How do we do that? There are two ways. One is the approximation method and one is the rigorous method. Okay. So approximation method, it's relatively simple. Once we have that matrix in the form of rows and columns, okay. So you do the column wise sum and then normalize each value using this column summation, and then whatever values we get, you average the rows to get, if it is a 3 by 3 matrix, you will get 3 values when you take the average of these 3 numbers row wise. So sum column wise and normalize the values column wise, average each row to get the priority weight. That is the approximation method. And rigorous method is use the principal eigenvector approach, where you like calculate the determinants of the matrix and find the maximum eigenvalue, and using that get the priority weights. But in this course, let us stick to the approximation method, as it is relatively easy to understand, and for any of these tools, AHP, Topsys or different MCDMs, you would find there are online links and tools which are available. Also the softwares like Scilab, MATLAB or even Excel sheets, you can develop your own models which can calculate and give you this principal eigenvector without much effort. So once we calculate these priority vectors or weights, they represent relative importance of criteria first, and then relative importance of alternatives under each criteria. So if there are like say 3 criteria, first we have to know amongst those 3 criteria which is more important, which is less important. So the first pairwise comparison matrix should be only for the criteria based on the data collected for the criteria, okay, and then you obtain this priority vector for criteria and list down which criteria is relatively more important or less important. Once that is done, consider one criteria at a time and compare all the available alternatives for each criteria. So for each criteria, let us say if there are 3 criteria and 5 alternatives. To compare 3 criteria amongst itself, we will have a matrix of 3 by 3, and then we will get 3 numbers or the priority vectors or weights for 3 criteria. Now under each criteria, when we have to compare 5 alternatives, we will get 3 more matrices of 5 by 5 order, okay, because there are 5 alternatives, and then for 3 matrices of 5 by 5 we will get the 5 values for those 5 alternatives under each criteria. So we will be having 5, 5, 5, 15 values, okay. So that will give us the relative performance of alternatives under each criteria. Once we let me just show the criteria thing, the approximation method. So if this is the matrix considered similarly like 1, 3, 5, you have the diagonal elements, you have the reciprocal elements, okay, you shift it along the scale wise 3 to 1, so it is 5 to 3, then this becomes 1 by 3. So you take the sum column wise, so 1 plus 3 plus 5, how much? 5 plus 3, 8 and 1, 9. So it is 9 here, here it is 4.3, here it is 1.53. Once you do the sum column wise, you normalize the values column wise. So how will you normalize? You divide each entry by sum. That's so 1 by 9 will give you this, 3 by 9 will give you 0.33, and 5 by 9 will give you 0.556. Similarly, in the second column, this 1 by 3 upon 4.3, it will give you this number. So you do column wise normalization. So first sum of columns, column wise sums then normalize each value column wise, and third step is average out each row. So, you take this plus this plus this, the average of these 3 numbers will give you the weight 0.106. Similarly, for this 3 values average 0.26 and these 3 will give you something 0.63. So, this final priority vector, it gives you the weights for the criteria. Okay. Similarly, under each criteria you have to do for alternatives, but I think that will be more clear when we take a real example. So, for now I will stop here only with the weights of the criteria. Okay. So, this was basically to show you how the approximation method works. Okay. Sum column wise, normalize and then take the row average. So, that gives you the weights or the priority vector for a comparison matrix. Fifth step is, once you get the matrix, once you get the weights, you check the matrix for its consistency. Okay. So, this consistency step is to check whether the judgments which are made or the data which is collected based on the experts opinion or the survey, whether it is logical or not. Okay. For that, we use the maximum eigenvalue from the comparison matrix, and then there are two steps. One is to check consistency index, which is lambda max minus n by n minus 1, where n is the number of criteria when we are dealing with criteria, or alternatives when we are dealing with alternative matrix. Lambda max is the maximum eigenvalue, and once we get the consistency index, we divide it by random index to get consistency ratio, and if this consistency ratio is less than 0.1, the matrix that we have prepared based on the collected data is acceptable. Okay. Random index, it is like a universally known based on Slattery's table. These are some fixed values for different set of matrices. So, if there are say like, because obviously if there is just one criteria, two criteria, we do not need AHP, but as soon as the number of factors or alternatives become 3, 4, 10, 15. So, for the numbers from 3 to 14, these are going to be the random indices, which you do not need to remember. It would be given to you. If there is a question on calculating consistency index or ratio, then random indices need not be remembered. Okay. These are usually provided in the exam, but if consistency ratio comes out to be greater than or equal to 0.1, then the matrix that we made for pairwise comparison, it is not acceptable. We have to go back to our data, to our survey respondents, and ask some more questions to get some consistent values. So, interpretation as shown in that table, if it is less than 1, less than 0.1, it is acceptable. If it is greater than 0.1, we have to revise the comparisons. And in AHP, sometimes it happens like when we collect data from surveys, the human judgments may contradict themselves. Like if you take example of say A and A, B, C, comparing 3 parameters, some person may say, okay, A is more important than B, I am representing more importance by greater than, and they may say B is more important to them than C. So, mathematically it happens, it should be like A is more important than C, but while responding to survey questions, the person they may say that okay, C is more important to than A, and now in such case there will be inconsistency, and that inconsistency in the responses would be flagged when we have this calculation, when we have this parameter of consistency ratio checked. This is for explanation, but some sort of inconsistency is allowed. That is why we are not having, we have some range, some thing is, there is some room for error or some room for what we say, the errors in the judgment or the data collected, but they can't be highly inconsistent and we cannot proceed with those inconsistent metrics. So, AHP will flag this. The last step, once you get the criteria scores or the criteria weights, once you get the weights or scores or ratings of alternatives under each criteria, you multiply both of them. You multiply criteria weights by alternative weights under each criteria, and you do the summation across all criteria to give you the final ranking or final overall weightage or priority score. So, that is the last step of AHP. So, to summarize, in this lecture we saw like what is multi-criteria decision making methods, how can they be helpful. There are 2 types of them, multi-criteria multi-objective based or multi-attribute based, and in one case there are finite set of alternatives, in other case there are infinite alternatives. AHP, it is mainly used when there are finite set of alternatives, and it is used across via diverse sector, and there are 6 steps that we saw in calculate in the AHP. It's not like mandatory that you have to mention that there are 6 steps. In some books it can be 4 steps or 5 steps also, but remember the flow. First you prepare the pairwise comparison matrix for criteria, and I have explained how to fill that pairwise comparison matrix. The diagonal elements should be 1, reciprocity of reciprocal nature of the matrix should be maintained, and then once you get the weightage of criteria, for each criteria do repeat the same thing for alternatives. Okay. For each matrix that you deal with in AHP, check for consistency. Consistency check is consistency ratio should be less than 0.1, and it depends on random index and consistency index, which you can calculate from maximum eigenvalue of the vector. And then you just multiply the criteria weights by alternative weights and do the summation to get the final score. So, those were the 6 steps in AHP, and in next class we will see one example so that you actually know how do we apply AHP numerically. Thank you.